Hi, in this video we will do some examples in which we will describe the span of a given set of vectors. Here I have three vectors from R3 and the question asks what is the span of these three. Well, the span will be the linear combination, all possible linear combinations of these three vectors. But to describe them, we will look for values of x and y, z. So what are the x, y, and z values such that the vector x, y, z is well, in the span of these vectors, so in other words, is a linear combinations of these v1, let me call them v1, v2, and v3. So that's just translation of the question in different way. So in other words, we're trying to see for what values of x this system, remember, to check if x, y, z linear combinations of these vectors, we form this augmented matrix whose coefficient part comes from the columns of coefficient parts are the vectors, and the right hand side is the vector we are trying to check if it is the linear combination or not. So we have to see if for what values of x, y, z this guy is consistent. Now for what values of x, y, and z. In other words, solve this equation, yes? So we row reduce it. What do we do? Okay, so let me first thing multiply the row 1 by 1 over 3, so get 1, 0, 1, x over 3, and let me just keep it that way. Okay. Now we can get rid of this negative 1 by adding row 1 to row 2. Also, we can get rid of this one by adding negative 2 times of row 1 to row 3. So this guy will be 0, 1, 2, and here y plus x over 3. This other one will give us 0 here. 1 stays the same, and 4 minus 2, 2, and z minus 2, 2/3 of x. And this guy is, the first row is the same as before. Very nice. Now we have to get rid of this piece here. So for that, I will do subtract row 2 from row 3. So this will be 0, 0, 0, and here we z minus 2x over 3 minus y minus x over 3, so plus, sorry. And then the rest is the same as before, yes? 1, 0, 1, x, and y plus x over 3. So this is row echelon form, obviously. And the system to have consistent, or to have a solution to be consistent, we need the right hand side of this row equal to 0. Otherwise, this is inconsistent. So the system is consistent if and only if the right hand side of the third row, which is x, z minus actually x and minus y is equal to 0. So I computed this is x minus z minus x minus y, and it must be equal to 0, otherwise the system is inconsistent. Well, when you look at this guy, you see that this is the general form equation of a plane. And yes, the span of these three vectors is the plane with this equation. So the span, let me just write here, is the plane in R3 with the equation z minus x minus y equals to 0. So that describes everything we are interested in to know. Okay. How about this other one? Okay, so we are trying to find linear, all possible linear combinations. Again, we are trying to see for what values of x, y, z this system is consistent. So is consistent for what values? So we find those ones, and based on that, we describe the whole setup. So we have to row reduce this. So here I have to make these two 0. So for that, we have R2 plus R1 and R3 plus 2 times R1. And as you can see here, this will give us 0, 0, and y minus x. That's nice. Oh, y plus x. And this other one 0 and 0, and then z plus 2x. And the first row is this. And as you can see, this is row echelon form. And we can now determine for what values of x, y, z this system is consistent. So the system is consistent if and only if, you see, these guys are 0 on the left hand side. They must be 0 on the right hand side too. So y plus x is equal to 0, and z plus 2x also needs to be 0. And well, you note this thing. What is this? This is the general form equation for a line. Indeed, we can simplify this and find the vector form of this guy. So for example, you see I can write y is equal to minus x and z is equal to minus 2x. And this means what? This means that if I set x equal to the parameter t, my x is going to be t times 1, y is going to be minus t, and z is going to be minus 2t. In other words, the vector form of this line, which is the span of these vectors, is 1, negative 1, negative 2 times t. So this is the vector form of that line. We not only have the general form, but also vector form of the span of those two vectors. And let's do one more example. Here we are in R2, so we are trying to see for what values of x and y this system is consistent. For what values? So, well, we make this guy 0 by row 2 minus 2 row 1. So this will be 0. Minus 4 plus 1 negative 3. And this will be y minus 2x. And then 1, 2x. And this is row echelon form. This has all the properties of row echelon form. And you see that there is no left-hand side 0. So this means that this system is always consistent. It means that no matter what you put for x and y, the system will be consistent. In other words, span of 1, 2 and 2, 1 will include all the vectors of the form x, y for all x and y. This means what? This means that the whole R2 is actually the span of these two vectors. In other words, the whole R2 is a span of 1, 2, 2, 1. And these were the examples. As you saw, this can be, span can be a line, a plane, and the whole R2. The whole R3 can be also the span of some vectors in R3.